So this topic is quadratic relations, chapters 4, 5, and 6, including factoring and the word problem questions. We're going to go through little bits and pieces of it, and then we'll leave some for you to practice tonight. These three examples in question number 1 ask you to use the finite differences. Finite differences just mean first and second differences. So the first differences are the change in the y values. For example, from 4 to 5, it goes up by 1. 5 to 6, it goes up by 1. And second differences are the change in the first differences. We only calculate second differences if the first differences are not the same. Okay, so go ahead and calculate your first and second differences where they apply, and think about whether the function is linear, quadratic, or something else entirely. 1 minute, and then we'll talk about that. Oh, you didn't ask questions, wasn't you? Yep, that's right. Mm-hmm. What A does. We'll talk about these things. Alrighty, the first differences. Each of these, now they're green. Each of these is increasing by 1 each time. If I wanted to calculate that, I would just go 5 minus 4, 6 minus 5, 7 minus 6, 8 minus 7, and so on. Okay? Yep. Isn't it easier to go from the bottom left? From the bottom down here, this way? Yeah. Sure you can. The same thing, doesn't really matter. 8 minus 7, 7 minus 6, and keep going. Okay. So, when the first differences are all the same, what does that tell you about the type of function? It's linear. So, linear means the first differences are equal. You guys have a really good foldable from chapter 4 that has all this stuff in it as well. From 3 to 4 goes up by 1, because 4 minus 3 is 1. From 4 to 7 goes up by 3. 7 minus 4 is 3, and so on. First differences are not the same, so it's not a linear function. We're going to calculate the second differences. These are just the change in the first differences. 3 minus 1 is 2, so this went up by 2. From 3 to 5, it went up by 2, and 5 to 7 also went up by 2. When the second differences are equal, what kind of function is it? Quadratic, yes. So second differences are equal, that means it's a quadratic function. Quadratic. Second differences are equal. How about the last one? From 0 to 1, it goes up by 1. From 1 to 8, it goes up by 7. From 8 to 27, goes up by 19. 27 to 64. 37. I don't know if it's 6. Oh. 37. There we go. So not linear, first differences are different. From 1 to 7, went up by 6. 7 to 19, went up by 12. 19 to 37, went up by 18. So again, not second differences are equal either, so it's neither. Okay, if nothing's the same, it's neither linear nor quadratic. Questions about this at all? Okay, so the 3 forms of quadratic equations that we've looked at are standard form, vertex form, and factored form. So I'm going to put those in there, and then we're going to talk about what each form gives us. What can we see that's common to all of the forms? What does the A value tell us? John? The step pattern? Yes, it does. The A value tells us if it's stretched or compressed vertically, which gives us the step pattern. What else does A tell us? Yep, Sam?
If it's positive or negative?
Positive A value means it opens up and has a minimum, right? If it's negative, it opens down and has a maximum. So that's definitely what we can see from the A value. What else can we tell from A?
Is it like the width?
Yeah, if it's wide or if it's thin, right? If it's stretched vertically, it's going to be narrower. If it's compressed, it'll be wider. So we're looking at, whoops. We're looking at the A value to tell if it is wide or thin, which means it's stretched or compressed. You don't really need to write them both if you don't want to. In fact, you don't need to write anything if you don't want to, but that's the stuff you can find it from the A value. It tells us the direction of opening, so if it has a maximum or minimum. And also we use A for the step pattern. Right? When we're graphing, how much do we go up or down by? Depends on the A value. Sam?
So if it's compressed, wouldn't it be thin?
Because we're talking about vertical, think of stepping on a pop can. If you compress a pop can or you compress a box, it gets wider and shorter, right? It goes out because you're stepping on it. So if it's vertically compressed, it's actually going to be wider and shorter. And if it's vertically stretched, it's going to be narrower and thinner. Depending on what the A value is, you'll know which one that is. If the A value is greater than 1, stretched is when it's more than 1, and compressed is when it's less than 1. What can we see from standard form? What does only standard form give us? Jonathan?
The y-intercept.
The y-intercept, yes it does. What does vertex form give us? Gene? The vertex. And what does factored form give us?
The zero.
The zeros, the roots, the x-intercepts. So those are the important parts of each of those. We can see the vertex, the roots, and the y-intercept depending on what form we're looking at. We can also use those forms to find other information. Right? If we have an equation in standard form, and we want to find, let's say, the vertex from standard form, what could we do? We have standard form, we want the vertex. Wait till I see some more hands too. Think, how do we get the vertex? We have standard form, ax squared plus bx plus c, and we got to change it around to get the vertex. Okay? Gene? You have to complete the square. That's the hit and squit process, right? So you change it from standard form to vertex form. When you have an equation that's already in vertex form, the vertex is given. If it's not in vertex form, you have to change it around. So in order to get vertex form, we're going to complete the square. That's the main way that you're going to find the vertex. Is there any other way, if you have standard form, that you can get the vertex? If you don't want to complete the square, I know, on purpose. A point on it would let you solve for the A value but not for the vertex. What if you want to get the vertex but you don't want to complete the square? You forget how to hit and squit. What else can you do? John?
Put it into factored form and then like add the two roots together and divide by 2.
That's a good option. You could put it into factored form by factoring, and you could just average the roots. Right? Okay, so let's talk about some of the things you might want to write down. The key features are things you'd like to note, especially for standard form, vertex form, and factored form. So we talked about those 3. C is the y-intercept. H, K is the vertex. We can switch the signs. And R and S are the roots.
Don't you only switch the sign for h?
Everything in the brackets is backwards, always. So if you have anything in the brackets, whether it's your P and Q from the equation of a line, or whether it's the quadratic function equations, you have to switch the signs. So same thing for R and S. Y-intercept, vertex, and the roots or the zeros. And we said that if we want to find the vertex from standard form, we could complete the square.
Square.
And that's a good option. Then John said if you don't want to complete the square, he could average the roots. Right, factor to get the roots and average them. That's another one. What's the shortcut I taught you? That's kind of a third option that we don't do very often. No, that's for factoring. We'll use that a little bit later. The axis of symmetry has a tiny equation that you can use to check sometimes. negative b over 2a. It's like the first part of the quadratic formula. You get it by averaging out the roots with the formula. So negative b over 2a, you can use that to find the axis of symmetry if you want to. Or you factor to find the roots. That's what we were talking about before. Average the roots, and then substitute that back in. Those are the three ways to get the vertex if you don't have it already given to you in vertex form. You have a really, really nice chart in chapter 6, right near the word problem section that talks about what I could ask you to find. If I ask you for, let's say, the maximum height, that means find the vertex, then it's listing the ways to do that. That chart's going to be a good one to study for this topic as well. What if you can't factor? It says factor to find the roots. Yep, Jane? That's part of factoring.
Complete
Right.
the square.
That's to find the vertex. What if I want the roots and I can't factor?
Oh wait, quadratic formula?
Yeah, use the quadratic formula. So there's the formula. If you can't get the roots by factoring, you can use the quadratic formula, the one with the square root sign in it. And that'll give you the roots, and you can average them from the formula as well. What else could I want you to find from standard form?
Excuse the interruption. Please excuse all junior and senior basketball players at this time. Thank you.
What's EQN?
Equation. I was just lazy, sorry. What else can I ask you to find? Vertex, roots, or? That's part of the vertex, yeah. Jean? That's also part of the vertex, but that's true. I could ask for those things. What could I ask for that's totally different? Yep. The x-intercepts, which are like the roots. Keep going. The y-intercept, right? That's the only one we didn't put up here. How? And the symmetrical point, absolutely. How would we find the y-intercept if it weren't given in the equation? Yep, Jean?
Reverse factors into FOIL?
You could, use FOIL to expand it, or
So x equals 0.
you could put x equals 0 in there and that would work as well. Good stuff. Okay. When the vertex is on the x-axis, there might not be a b term. When the vertex is on the y-axis, or on the y-axis, sorry. When the vertex is at the origin, all you're going to have is one term in the equation. Right? Know that there's some special cases when you have an equation that's just translated up or down, like this one, up 5 units. You know by looking at that equation, it's only translated up, so the vertex is 0, 5. Okay. Any equation that looks like y equals ax squared will have a vertex at the origin. So sometimes you don't even need to worry about figuring out the vertex. You can look at the equation and you just know, right, based on the types of functions you've looked at before. All right, so for vertex form, we talked about the fact that it gives you the vertex. You guys probably already jotted that down. If I wanted you to find out other information from vertex form, what could I ask you for? Yep.
I have a question now.
Sure.
If y equals ax squared, how do we prove that we know what the vertex is? How do we make that?
The vertex is 0, 0 because it's not translated, right? 0 units to the left and right and 0 units up and down. It's not moved anywhere else. In vertex form, if you're given the vertex, you guys mentioned some things that I said were sort of like the vertex. The axis of symmetry, the maximum, minimum values. How do I find those from vertex form? Which part of this big long equation would give me the axis symmetry equation? Which part of this would give me the axis of symmetry? Somebody quiet who hasn't said anything yet today. What do you use for your equation? X equals a number, but where does that number come from? The h, good. It's the h, the x coordinate of the vertex. So we use h for the axis of symmetry equation. And what do we use the k for? Min or max value. Okay. You already have this in your notes, so if you don't want to write it down, you don't have to. It's up to you. Whoops. So use k for the max or minimum value.
Wait, but how can x equal h if they're both in the same bracket?
The equation of the axis of symmetry is x equals a number, but you're going to use the h as a number. I think the way I wrote that down before was confusing to you, but is that better? That's the equation, x equals a number, and you're going to use the h for the number.
Okay, so you just like kind of just type.
So if it was negative 2, it would be positive 2, x equals 2. Okay. And to find the y-intercept, just make x equals 0 and solve, or do what Jean said, use FOIL and expand to standard form. All right, with factored form, same thing goes. If you have the roots, how could you find the vertex? Average them, good stuff. And if you have the roots and you have factored form, how could you find the y-intercept? You could expand it, absolutely. You could multiply everything by a and then use FOIL and expand it to standard form. That would work. Probably it might be a little faster to also just find the y-intercept by plugging in x equals 0 because you don't have to do as much work. I picked the easiest method, but they're all good. Questions with this page at all?
Wait, what's SN?
Standard form. When you're finished jotting down anything you want to, I want you to try number 3. Writing down the transformations for each parabola is listed. With the proper words, yeah. Reflected in the x-axis, stretched vertically by a factor of whatever it is. Translated a certain number of units up, down, left, or right.
Point form.
Point form's fine, yeah. I'll give you 2 minutes.